On behalf of Intandem Research Club, I welcome you all to Department of English at Marist College. I'm Mahalakshmi, a first MA English Literature comparer for this delightful evening. We have a theme-based series for this academic year 2023 to 24 titled Interdisciplinary Literary Studies with today's topic Literature and Math. The perceived boundary between math and literature is actually a very recent idea. For most of recorded history, mathematics was part of every educated person's cultural awareness. There is a deeper reason we find mathematics at the heart of literature. The universe is full of underlying structure, pattern, and regularity, and mathematics is the best tool we have for understanding it. That's why mathematics is often called the language of the universe. Today, we have a vibrant keynote speaker, Dr. Padma V Mckertich is currently assistant professor in the Department of English, Stella College, Chennai. I welcome you, ma'am. I also welcome the paper presenter, Ms. Prema, lecturer, Department of Science, Fullinfaws PU and Degree College, Bangalore. I welcome you, ma'am. I extend my warm welcome to faculty members, research scholars, and PG students who are present at this forum. I deem it an honor to introduce our keynote speaker, Dr. Padma V Mckertich. Ma'am is currently working as an assistant professor in the Department of English, Stella College, Chennai. Ma'am did a philosophy at the University of Madras. Her research focuses on the Indian fiction in English and the bachelor's in the 1980s. Ma'am had published various chapters in different genres of literary national and international journals. Her publications include such as in Indian literatures, literature and science, feminism, Baptist studies, and so on. Ma'am have translated Ramakrishnan's Tamil play Aravan in English and also co-edited a collection of translations titled Four Tamil Plays and an anthology of essays on interfaith dialogue titled My Faith and Others. We are greatly blessed to have you at Miss Ma'am. Today's symposium scheduled as a paper presentation followed by the keynote address. Now, I request Ms. Prema, lecturer, Department of Science, Fullinfaws PU and Degree College, Bangalore, to present her paper on literature and math. Over to you, ma'am.
Good evening, everyone. I'm Prema, lecturer of mathematics from Fullinfaws PU and Degree College. Today, I'm here to give represent a paper on literature and math. Math and literature may seem to be like two things that are not even least bit connected to each other. It seems like they are two different cultures, opposite poles. Once upon a prime, Sarah Hart. Prime. Prime numbers are numbers which are divisible by 1 and number itself. Prime numbers are extremely important that they are even used in cybersecurity. C.P. Snow opens the 1959 essay The Two Cultures with an anecdote about a dinner at Cambridge. A visiting historian attempted to make conversation with the men on either side of him who were clearly uninterested. The host quickly explained, those, those are mathematicians. We never talk to them. The gap between Snow's two cultures, that are that of humanists and that of scientists. There is no narrower in 2023. The wondrous connections between mathematics and literature. In Once Upon a Prime, Sarah Hart tries to find relationship between mathematics and literature. I'm a mathematician, and despite my interest in literature, my intellectual priorities did not include novels, she says. Hart finds mathematical influence in literature itself. She unfolds the permutational structure governing poetic forms like sestinas. Poems written in sestina form, instead of using rhyming verse. The poem makes use of repeating words. There are 6 lines in each stanza, each of which ends with a different word. Those 6 words are then reused at the end of each line in the subsequent stanzas, but the order of each word changes. The Painter by John Ashbery, stanza 1. Sitting between the sea and the buildings, he enjoyed painting the sea's portrait, but just as children imagine a prayer, his merely silence, he expected his subject to rush up the sand and seizing a brush, plaster its own portrait on the canvas. Stanza 2. So there was never any paint on his canvas until the people who live in the buildings put him to work, try using the brush as a means to an end, select for a portrait something less angry and large and more subject to a painter's moods or perhaps to a prayer. A winter's feeder, Craig Kidner. So here you can observe the same pattern of repeating the words. Mathematics in poetry, the Fibonacci poem. Fibonacci series. Fibonacci series is even associated with the arrangement of petals in flowers. Fibonacci is also used to create art. The Fibonacci series is a mathematical pattern starting with 0 and 1. Each number next in the sequence is the sum of the preceding two preceding numbers giving 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Fibonacci poetry, or the fib, is a poetic form created by Gregory K. Pincus that is modeled after the mathematical Fibonacci sequence. Mathematics in poetry, the Fibonacci poem fib. A 6-line Fibonacci poem has syllable counts of 1, 1, 2, 3, 5, and 8 in each line of the poem. One syllable for the first line, one syllable for the second line, two syllables for the third, three syllables for the fourth, five syllables for the fifth, and eight syllables for the sixth. Mathematics in poetry. Fibbing can be fun. One small, precise, poetic, spiraling mixture. Math plus poetry yields the fib. Stars, fun and moon, oceans, blue, in God's own image, He did to create me and you. I wrote a poem on a page, but then each line grew by the words some of the previous two until I started to worry at all these words coming with such frequency because as you can see it can be easy to run out of space when a poem gets all Fibonacci sequency. Mathematics and the Da Vinci Code. Actually, pi is generally considered the most beautiful number in the universe. As Professor London loaded his slide projector, he explained that the number, the divine proposition phi, was derived from the Fibonacci sequence, a progression famous not only because the sum of adjacent terms equaled the next term, but because the quotient of adjacent terms possessed the astonishing property of approaching the number 1.0. 618. 5. Mathematics and the Da Vinci Code. Measure the distance from the tip of your head to the floor, then that the divide that by distance from your belly button to the floor. Guess what number you get. Measure the distance from your shoulder to your fingertips, the distance from your elbow to your fingertips, another hip to floor divided by knee to floor, finger joints, toes, spinal divisions. My friends, each of you is a walking tribute to the divine proportion. Mathematics and novels. Mathematicians try best to make math understandable, requires so much new terminology and notation that it may look unintelligible to the unintelligible to the uninitiated. In the math code, a short story, a kidnapped mathematician takes advantage of mathematical notation to send a secret message to his colleagues. The message is supposed the message is supposedly the statement of a theorem which he proved. However, it makes no sense mathematically. Another professor realizes that message is not in the mathematical content but in the notation itself. This story appears in the collection Reality Conditions. Thank you.
Thank you, ma'am. Now, I request Dr. Padma V Mckertich to give her comments on the paper presentation.
Good evening. Am I audible? Am I audible?
Yes, ma'am.
Yeah, thank you. Ms. Prema, it was a pleasure listening to you, especially because I think among a whole group of literature people, it's very nice to hear someone speak of literature from the mathematics discipline. Uh, you've also said a couple of things that I wanted to say in some time. But thank you so much for bringing out the close connections between literature and mathematics, particularly in poetry. Uh, and it was nice that you gave so many examples for most of the forms that you had mentioned. Thank you so much. It was really a pleasure listening to you.
Thank you, ma'am.
Thank you, ma'am.
First, Dr. Padma V Mckertich to give her keynote address. The forum is yours, ma'am.
Thank you, Mahalakshmi. Just give me a minute. I hope yeah, I think the screen is visible. I hope I'm audible also. Uh, you'll have to excuse the stuffiness that I'll be talking with. Uh, and I hope my internet doesn't play up as it has been playing up in the past few minutes. But I would like to begin with a little bit of, what shall I say, a little disclaimer. When Dr. Maria Preeti asked me if I will give the keynote today, my first thought was of my colleague skills, or more specifically, he used to despair of my lack of math skills. He tried a lot, but he could not write properly. And somewhere along the line, he also tried to make me learn all the formulae plus b the whole square. Doing his maths till I was in 12th standard, I never really got the hang of those formulae. Some tried to teach me a little bit of calculus, but I think along with the whole string of my maths teachers in school, he also gave up. So I think eventually when I became a teacher, I think he heaved a huge sigh of relief, and I think many of my. But the thing is, even now, sometimes I have nightmares that I'm in my school, trying to write a maths exam, and I have not prepared. It was only when I started working on I wish I could go back and do a little bit of the maths from school, but well, I guess not possible. So I guess the part of the relief that my father felt that he didn't have to deal with my not being able to deal with maths. Ah, my voice is breaking. I'm inaudible at times. Can you give me a minute? I'll try and. Is it better now?
Better.
Sridhar ma'am, can you give me a minute? I'll see if I can change my earphones. Just give me one minute.
Sure, sure. Yeah, you can change if you want. At the moment, you're audible.
Maybe just a minute. If I'm audible, then I think I'll continue. So, I was saying that I think one of the reasons, I think a lot of people feel this divide between literature and maths is that we tend to think that, the two of them are, two opposite sides of the coin, as Mahalakshmi mentioned in the program. So, in the sense that maths is known for being very precise, it's known for being very accurate, and
I think you must change
not be.
your mic. I think you must change your microphone, Padma. Every time it's breaking. Now it's no more.
Yeah, I'll just change my. Am I audible now?
Yes.
Okay, so I'll keep my camera off. Maybe that's interfering uh, with the internet connection. So, like I was saying, 30 maths, for example, tells us things in very precise and specific terms. 13 times 13 is 169, but it also tells us that it cannot be 168.9 or 169.1. And this precision of maths is something I think very important, because that is the basis of a lot of life saving instruments, of path breaking technology. And literature is often the other extreme. I mean, for instance, was Macbeth a hero? Was Macbeth a villain? Why did Iago do what he did to Othello, to Desdemona, to Brabantio, to Cassio? I mean, there surely should have been some easier way to become the lieutenant. So, literature thrives on ambiguity, whereas math seems to thrive on specificities and precision. So, the field of literature and maths, therefore, I guess, is something that people assume occupy two opposite ends of the spectrum. But nevertheless, today, maths and literature is a pretty well known field. And there are quite a few handbooks available on studies of literature and maths. There is a Palgrave Handbook of Literature and Mathematics, the journal called Journal of Literature and Science, that's published by Cardiff University, also has an issue dedicated to literature and maths. But still, maths is not exactly a science like physics or chemistry is. So, for instance, in India, a lot of universities offer maths as a science course. We do a BSc in mathematics, but a lot of colleges and universities in India and abroad actually offer a BA in maths, a Bachelor of Arts program in maths. Now, the difference between the two is somewhat important, I feel, because when we look at a BSc program in maths, the focus is also as much on mathematics as it is on the applications of mathematics into physics, into computer science and business and chemistry and many other subjects. But if you look at the Bachelor of Arts program in mathematics, the focus is very largely on the abstract concepts in maths. Because if we actually look at it, maths among all the sciences, if you look at maths as a science, because maths actually does not have two of the features that are associated with a science discipline: observation and experimentation. Traditional maths does not have. So it's pure abstraction. So 13 times 13 is 169, is actually sorry, is it once, yeah, 169 sorry, is pure abstraction. We may say that 13 times 13 oranges are 169 oranges, but that is our application. You don't need a real life referent to come to that conclusion. And like most of us who have worked on Kant or many philosophers, we would be able to recognize the a priori concept that mathematics is. But this then brings us to something that mathematics and literature share very closely, I think, and that is the love of form, as I think Mahalakshmi mentioned. The love of form, the love of structures, and the recognition of the beauty in these forms and structures. Um, Almost all mathematics deals with some kind of form or the other, and particularly geometry does. And even before structuralism, I think literary criticism had thrived on structure. So even a cursory glance at Aristotle's Poetics would reveal that he's actually talking about the structure of the Greek tragedy. And anybody of us who's familiar with the Tamil Sangam poems and the entire poetics of the Sangam world are familiar with the forms, that the formal and structural features of such poetry. So I thought I could look at some of these intersections between literature and science. So to begin with, I thought we begin with the understanding that a lot of literature has references in some form or the other to numbers, just numbers, sometimes operations between numbers. And actually, a lot of these numbers repeat themselves almost like archetypes. And this repetition often happens in mythic narratives or religious narratives or fairy tales or folk tales. And these, if we recall, are narratives where archetypal patterns like quests and journeys also repeat themselves. Now, of course, archetypal criticism has spent a lot of time and energy on analyzing these. But one of the foundational texts where numbers are used in a major way, this is again a random selection, is Dante's Divine Comedy. We always go back to Divine Comedy. Of course, there are the numbers in each of the three levels. So there are the nine circles of hell. There are the seven the nine circle. There are the nine circles of hell, the seven terraces of purgatory, and the nine celestial spheres of heaven. These, of course, Dante drew heavily upon the cosmology of the Italy of his time. But at the same time, he goes a little further, because what studies have shown, and this is one of the more popular areas of study in literature and maths, how Dante not only represents the cosmology of his time, but also combines this with Aristotelian ideas of form and mathematics. So, for instance, towards the end of the poem, his guide in Paradiso, Beatrice, tells him that the material and the physical, material and the spiritual realms are not exactly separated from each other. So they actually come together and form some kind of a 3D sphere. So there are a lot of such, repeated mathematical references. For instance, again, Beatrice tells Dante that the divine is like the prime factor from whom all other factors emerge. Divinity also is often referred to in terms of numbers. And then, of course, we have the famous seven dwarfs of whom Snow White meets. We have the three boons that the genie often gives whoever releases the genie. There are the seven deadly sins. There are the other picture over there is a temple of the 64 yoginis in India. 64 because we speak of the eight Lakshmis, the Ashtalakshmi, and it's 8 times 8, 64. So numbers have always played a major role in different kinds of narrative. But like Ms. Prema mentioned, poetry seems to be particularly close to numbers because poetry deals a lot with rhythms, it deals a lot with meter and rhyme, and therefore it is also closely related to music. And we all know that music and mathematics are very closely connected to each other. What you have there is a scanned image of a poem, but at the same time there have been a lot of mathematicians who've been very good musicians and vice versa. So for instance, Einstein was a very accomplished violinist, I'm told. And the person you see there by the blackboard is Art Garfunkel of the Simon and Garfunkel duo, who was a master's in mathematics from Columbia University. The guitar over there actually follows the Pythagoras ratio in its construction. So the closeness of maths and literature, of course, is there. There are certain poetic forms that are very close to mathematics. Many of us may recall the haiku, the Japanese form. This is one example of the haiku. So you have 5, 7, and 5 syllables. It's a very strict form in the sense that it has to have 3 lines, 5, 7, and 5 syllables. A similar one is the Sankain, which has 5 lines. It has 2, 4, 6, 8, and 2 syllables. Probably the most mathematical of the lot is the poetic form that Miss Prema mentioned. Now, this is the sestina form, as she's already spoken about it, where you have the order of the words over here, and the reason why the last word of each stanza of the first stanza repeats in that order is to form the spire in the center that you see in the center. So you have a very strict mathematical code over there. Many of us who are familiar with Tamil forms may remember the Andadi form, where you have the last word of one stanza being the first word of the next stanza, and the last word of the last stanza taking us back to the first word of the first stanza. So mathematics has usually been very closely related to poetic forms as well. This is another example of a sestina. So you, for instance, if you take the word harvest, you have it in the first line here. You have it in the second line in the second stanza. You have it in the 1, 2, 3, 4th line in the third stanza, and so on. So this is one more example. Ms. Prema had already shown us a few examples. So there is another poetic form, though, that is very specifically associated with maths, and that is the sonnet form. And I would like to spend a little time on this. And for this, I would like to draw entirely, none of this is my own. This is something that I'd like to draw entirely upon an essay titled Beauty Bear, the sonnet form, geometry and aesthetics. This is written by two people, a mathematician and a literary scholar. The mathematician is Matthew Chiasson, and the literary scholar is Janine Rogers. And the article uses this sonnet by Edna St. Vincent Millay. Euclid alone has looked on Beauty Bear. Euclid is a reference to the geometrician Euclid and his linear geometry, and I'm sure Ms. Prema will know the exact term for that, but the straight line geometry, and not the geometry that uses non-real numbers. And the idea that geometry can take us to the heart of beauty is something that is reiterated here. But this goes a little beyond that. Now, what do these two writers tell us? And I quote here, they say the sonnet form contains within it a mathematical theorem that is very beautiful. It also contains it very literally. The Petrarchan English sonnet with the octave, sestet, iambic pentameter stanza embodies two geometrical constructs exactly: the Pythagorean theorem and the primitive Pythagorean triple. So the Pythagorean theorem is something we are all familiar with, the right angle triangle and the square of the hypotenuse being the same, being equal to the sum of the squares of the other two sides. The numbers that you see there, 3, 4, 5, 7, 24, 25, are all Pythagorean triplets. Now, what the essay does is that it takes three important numbers in the sonnet. So there is 8, there is 6, and there is 10. 8 is the number of lines in the octave. 6, of course, is the number of lines in the sestet. And 10 is the number of syllables in each line. So if you actually do this, 8 square plus 6 square, you actually get 10 square. So you get 64 and 36, you actually get 100. So irrespective of what the sonnet is, the sonnet doesn't just, sonnets don't just refer to the Pythagorean theorem. The sonnet enacts the Pythagorean theorem. But it also goes a little further. So if you take the three numbers 8, 6, and 10 and you put them in order, 6, 8, and 10, you'll find that they are scaled up values of 3, 4, and 5. So they are 2 times 3, 2 times 4, and 2 times 5. And 3, 4, and 5 are usually called the primitive Pythagorean triple because they cannot be further reduced. And they are also the only Pythagorean triple which have three consecutive numbers. Now, it may seem like this is stretching things, but there is a historicity to this as well. What the writers tell us also is that in the same court of the court of Frederick II in Italy, where the sonnet was actually created, the first sonnet was created, the sonnet form came out. One of the courtiers was Fibonacci, about whom Ms. Prema spoke. And this was the time when Euclid's Elements was translated from the Arabic into into Latin. And Euclid's Elements actually contained the first and complete proof of the Pythagorean theorem. And this, in a way, has led a lot of people to recognize that the Pythagorean theorem in some way may have formed the zeitgeist of the period, and therefore in many ways was built into the form that almost represented the period. So that much for sonnets. There is also a reference that I found interesting. This is a group called the Ulipo. I'd read some of the poems, but I didn't realize that this was the group that had formed this. But this was a group that was created in the 1960s. I am not even going to try and pronounce the French expansion of Ulipo. It translates into Workshop of Potential Literature. And this was a group of people who were both mathematicians, either professional mathematicians, particularly graph theorists, or they were amateur mathematicians. They were also writers. There were some chemical engineers there as well. The group was formed based on the understanding or based on the belief that poetry, particularly, and mathematics, specifically poetry, but even generally literature and mathematics, share some very profound affinities. And the objective of the group was to propose some radically new structures to poetry. Just like in the sonnet form, the structure was that it had to have two quatrains forming an octave and two tercets forming a sestet, and that each line had to have had to be in iambic pentameter, and it had to have a particular rhyme scheme. So, like that was the constraint, or that was the structure that was available for the sonneteer. This group wanted to propose a radically new set of constraints or structures which were all drawn from mathematics. So they've produced a lot of books. One is a book called, it's a very interesting book. This is its French word. This is the French name of the book. It's actually called 100,000 billion poems. Why is it called 100,000 billion? That is how it was published with, in strips. The book actually contains 10 sonnets, but the sonnets are written in such a way that any line from any sonnet can be combined with any other line from any other sonnet to form a completely new sonnet. So the first line of the first sonnet can be combined with the second to the 14th line of the second sonnet, or it can be combined with the second line of the second sonnet, the 14th line of the third line of the 10th sonnet, the fourth line of the sixth sonnet. Any permutation and combination was possible, which meant that although what was published was 10 sonnets, the number of poems it actually contained was 10 to the power of 14, which meant that it was 100,000 billion sonnets. So many people call this actually a non-book. The other one is another constraint is called the Pilish poems. Pilish poems are poems where the number of syllables in every word or every line, subsequent line, correspond with the number of pi. So the most simplest one is how I wish I could calculate pi. So 3.1411592. You have very complex ones like the one shown there. This is yet another one. So you'll notice that every next word has the number of letters in the next word has to do with the number of the decimal point. I mean, the number that comes at that decimal point in the number pi. So this is something that was very interesting. But poetry, perhaps it's not very surprising that poetry has so many resonances with mathematics, given that poetry has got a lot to do with rhyme and rhythm. At the same time, we have a lot of plays as well, which deal with different kinds of maths. I'm just going to mention one, though there are couple of others. This is Arcadia by Tom Stoppard. It is, frankly, one of my favorite plays, but it's also a brilliantly crafted novel. And Stoppard, in his interviews, has said that he very consciously used chaos theory and fractal geometry here. Now, chaos theory is something that I think many of us are familiar with at some point or the other. It is a theory that essentially studies the dynamics of changing systems. But these are systems that change in such a way that any kind of long-term prediction becomes impossible with these systems. Now, this kind of challenges a lot of preconceptions about maths, because maths, like we saw in the beginning, was all about precision and being able to determine and about something being what it is. Chaos theory perhaps is best known by another term called butterfly effect. But the butterfly is also the butterfly effect because of the belief that a butterfly flapping its wings in the Amazon would lead to a tsunami in Japan. So this is the impact of any event. So there is that you cannot predict where the event will take you. At the same time, it is also it's also there is also the idea of being highly sensitive dependence on initial conditions, which means that depending on the initial condition, the results may completely vary, which is what makes, for example, predicting weather so difficult. Along with chaos theory, there is also fractal geometry, which itself posed a challenge to Euclidean geometry, because if you look at Euclidean geometry, you have straight lines, you have triangles, you have circles, which you do not actually find in nature. What you find in nature are slightly, not such perfect lines and triangles. So fractal geometry, among other things, is something that is used for plotting the shapes of leaves and coastlines, mountaintops, etc. But one of the important features of fractal geometry is that it does not deal so much with whole numbers And at the same time, it has what is called the similarity across scale, which means that as you scale out or scale in, you can see the same pattern repeating itself. We see this happening in the natural world, and a lot of maths has worked on creating new and more innovative patterns around this. So what Arcadia does is that it has two stories. They're set in two different times. One is set in the late 1990s. The other is set in the 18th century. The 18th century story actually features Thomasina, a young girl who is a mathematical genius and who actually anticipates chaos theory and fractal geometry. In fact, she says, "I'm going to plot this leaf," and in the space of the play, she actually discovers fractal geometry. Among the characters in the play, there are mathematicians who are working with iterative algorithms. Uh, and this particular mathematician is also plotting the population of grouse on the estate. There is also the similarity across scale that you see in the plot structure of the play. The plot of the play also shows a sensitive dependence on initial conditions. So, for example, something as
அப்படின்னு அங்க
seemingly
கேட்டது
small
வேற.
like a candle, a
அதுக்கப்புறம்
lit
அது கழிச்சு
candle
கொஞ்ச நேரம் வந்து
leads to a
பார்த்தா இங்க
fire
உட்காந்துட்டு அதுக்கப்புறம் வந்துட்டு
and a
இப்படின்னு
death.
நீ இப்படியே
Of course, this is something we can see in hindsight that most tragedy works with. Some small action on the part of the hero may have completely unexpected consequences. There are also props on the stage which actually iterate themselves. So they keep moving. The meaning that the props take on keeps iterating itself. Stoppard actually, like I said, made these references very consciously. But at the same time, he also called mathematicians and physicists to talk to the cast and crew of the plays when they were performed initially. Uh, Stoppard also used a different kind of physics in his next play, Hapgood, but unfortunately, Hapgood did not really become as popular as Arcadia did. Before I end, I'd like to make a brief mention of this very popular book, Alice in Wonderland, by Lewis Carroll, of course, who was actually a mathematician, Charles Dodgson, who narrated the story of Alice when he took the daughter of his school dean and her sister, Alice and her sister, on a boat ride. There are a lot of Dodgson was a mathematician and he himself wrote quite a few books, particularly on Euclidean geometry. There are a lot of studies on the maths in Alice in Wonderland, but I'd just like to mention two. One is the Cheshire Cat, and the other is the Mad Hatter's Tea Party. Now, the Cheshire
Like
Cat
இந்த மாதிரி
is one
ஃபேக்டர்ஸ்லாம்
of, I
கன்சிடர்
think, a
பண்ணணும் ஒரு
very
பிளேசர்
popular character. And at one point, Alice says she's seen a cat without a grin, but never a grin without a cat. And a lot of mathematicians point out that this was actually a snarky reference to the idea of imaginary numbers that have no referent in the real world. And remember, this was the time when the idea of imaginary numbers was catching on. But even more important is the Mad Hatter's Tea Party, where you actually have three characters. There is the Mad Hatter, there is a hare, and there is a dormouse. We are told that there was a fourth character, Time, who's not there now. And in the absence of Time, these three characters keep going round and round. Now, this has been related by a number of mathematicians to the idea of quaternons, which was becoming popular when Dodgson was writing or composing the novel, the story. So it actually refers to three imaginary numbers, I, J, and K, with a three imaginary dimensions, I, J, and K, with a fourth dimension, time. But the interesting feature that is relevant here is that the grid that you see there is actually the quaternion grid. So you'll see that in the quaternion grid, the yellow parts are a little interesting. So if you multiply I with 1, you get -1. But when you multiply 1 with I, you get I. So which means that the quaternion is not, that the sequence of the numbers matters in quaternion multiplication and addition. So that means that they're not commutative. So in regular mathematics, 4 times 3 and 3 times 4 are the same. 4 plus 3 is the same as 3 plus 4. But here, that's not the case. So at another point, in a little after this,
uh, uh, the Mad Hatter asks Alice, do you mean what you say? She says, yes, of course I mean what I say. And then she thinks and says, oh, but then I think I say what I mean, which is the same thing. And the Mad Hatter says, of course not, they're not the same thing. You might as well say I see what I eat is the same as I eat what I see. They're not the same thing at all. And because of this kind of what we can assume to be nonsensical chatter, this is something that a lot of mathematicians have connected with the historicity of the historicity of the text and the history of mathematics, and connected it to developments in mathematics that were happening at that time. Now, this is, of course, a very brief and a very broad overview. That I'm sure I'm sure, a lot of that have been lot of there are a lot of possibilities in looking at Indian literature and the use of mathematics in Indian literatures, because India did have a very strong and very long tradition of mathematics, as did the Arab world. In fact, if we recall, most of us write left to right, but all our mathematical operations happen right to left, because we follow the Arabic system of numerals. So I'm sure that is also there. So before I fully stop, I thought I'd leave you with a small puzzle. So there are a set of numbers here. There's one, right? Can someone guess the next number? Anybody? Oh, give it a shot. Nobody?
Ma'am, can I try?
Yeah, please do.
211.
Sorry?
312211.
312211. No.
Ma'am, is it 112211?
No. Sorry, what did the first person say? 31?
312211.
312211. Yeah, you're right. You're absolutely right. Can you tell us how you got that?
That is a very famous series from mathematics. It's called Look and Sim series.
Yes. Can you explain that?
So 1 1 2 is 1, 1 2 1 2. Then I'm
Yeah, you're right. What's happening is that every subsequent number, is actually a description of its previous number. So the first number has 1 1. So the second number is 1 1. The third number is a description of 11. 11 is 2 1. It has two ones there. So you have 21. So the fourth number is actually a description of 21. There is 1 2, and there are two ones. 1 2 and 1 1. Sorry, 1 2 and 1 1. There is only one number which can break this. That means the description of the number is the same as the number itself. Any guesses what that is?
yes.
Sorry? There is one number whose description is the same as the number itself.
Yeah, that
Only one.
No. I
three,
think
three.
it's a two-digit number. It's 22. So 2 2. 22 has 2 2. So if you come to 22, you break
What
this.
Padma? Is it 312211? You said, right?
Yeah, it's 312211.
Yeah, it's when you it's the description when you verbally
Yes.
describe it. It
Yes.
comes when you say when you verbally describe the 1 2 3 fourth line there.
Yes.
For fifth line,
Yes.
you get 312211. Okay.
Yes.
When you articulate it.
When you articulate it. So
Yeah.
very often we think of numbers and figures as two different things. But a lot of lateral thinking and the works with trying
Yeah.
to make us cross that line between figures and letters. Yeah. So I'll stop with that. Thank you very much.
Wow.
Thank you, Padma, for that very, very, I mean, still mind boggling. I mean, description of all, I mean,
Thank you, ma'am.
it is still mind boggling for me. Okay, too many things I got in today. Thank you for all that. It
Thank you,
takes,
ma'am.
because the only book I knew which had mathematics a lot was Alice in Wonderland and Through the
Yeah.
Looking Glass. That itself, I mean, and I used to think that was all, now I didn't know they corresponded to quite a lot of maths theories of the time.
Yes, ma'am.
For
Yes.
one thing, you've cured us of math phobia. And that point you made now about lateral thinking,
Yeah.
they say that we literature people are blessed with thinking out of the box. It's not exactly that. It
Not,
can come through various disciplines.
yes, yes,
And
And
some of the best literature, I mean, English teachers were also good maths teachers in school. Okay, that's what I
mm,
have noticed.
yes.
Yes.
and
I was
Padma, I
having
also know musicians, like people who's sight read and play music.
yes,
They may not good be as they may not they're definitely not good at playing by ear. And those who are very good at playing by ear don't take very well to sight reading.
yes,
And the notation in music, it requires that math brain
yes, very much.
to be able to, you know, transfer a notation to a message, a message in your mind.
Hmm.
Uh, that's that's one of the skills to make that quick transition in your mind to quickly transit this information, the notation, to read notation. That's great. Yeah.
I was very bad at maths in school. I was terrified of maths. Like I said, only when I started working on, I taught Arcadia for some time, and that's when I actually overcame that fear of maths and started to really enjoy it.
Mm, I think we should all, if we really have to grow in literature, we have to, explore interdisciplinary studies, because if we, I mean, literature be touching on so many subjects of so many areas of human life. We've got to know so many areas, right? Hey, Yasmin is here.
Yeah, I just saw. Whoa,
I know. Yes.
Jasmine.
Good.
I remember Yasmin and I went gaga over Da Vinci Code together.
Uh, any other?
One
Uh,
reference, I mean, what you said, Preeti,
hey, Vinita is saying something interesting. Three-dimensional art.
Ah, yes.
Mm.
no, we just said things about literature, right? Literature, I think, becomes richer for all its association with all these areas. Otherwise, I don't think we will have anything to talk about. Okay, because that's how we have increased our numbers. And today we are into so many. I mean, our dictionaries have become uh, bigger with all these references from all these. I think so. That's one advantage of interdisciplinarity. I think.
And Padma, what about cartography? No, a lot of the you're talking about shapes that are
Yes,
uh,
actually, cultures that had a strong mathematical foundation were usually involved in cartographic work. So,
uh,
and also, of course, the geography mattered in guessing because the closer you were to the sea, to any water body, the greater the, I guess, the desire to explore, and for
yeah.
that you needed the maps. But cartography is a wonderful area to work on. It's a huge study in itself.
Mm. It's lit, math, and geography. No,
Geography, yes.
lit, math, and also history
A
sometimes.
lot of history.
A
There is
lot
that
of history.
beautiful novel by K.K. Daruwala, no, For Pepper and Christ, where he brings in all of these. He brings in literature. I mean, of course, it's a novel. There is a lot of history. There is Portuguese colonization of India. There is geography. Uh, he brings in the African cartographers. It's a brilliant work.
What's the title of that novel?
For Pepper and Christ.
Ah, yeah, yes.
Yes.
Your candidate did that, right?
Yes, yes, yes. That's right.
Yeah. Sneha.
Yes, Sneha
Sneha.
did that.
Sneha.
Sneha did that, yes.
I think she's done such a great job. I think it'll be great, nice to record our response. You don't feel that you need to sound very scholarly. Just say what you feel. Students out there, Padma
Can
ma'am
I
would
ask
love
a
to know.
question?
Yes,
Yes, Alina.
Ma'am, I would like to ask Padma ma'am about Godot's incompleteness theorem,
so,
which provides the basis of
sorry, could you tell me what theorem? I didn't hear you.
Godot's incompleteness theorem.
You can
I,
text your message, Alina.
Okay.
I'm sorry, I don't know what it is. May I appeal to Miss Prema?
Alina, put it in the chat box. Alina, text it if you can, so that it's clear to.
And
Yeah.
thank you for Prema for setting off the mood.
Yes,
You started off with mathematics. I was wondering how a mathematics person could talk about poetry. So today you have read up English poetry also, and I think connected. So though it was brief, you have made a good attempt, Prema.
Yes, yes. I wanted to say that the poems she selected were really wonderful.
Yes.
The Painter by John Ashbery. That was lovely.
Yes, it's a beautiful poem. Uh, Alina, I don't know what the theorem is. I'm sorry, I can find out, but right now I have no idea what the theorem is.
Alina is a first year student, first UG, Padma.
Okay, that's
Mm. And she's come all the way from Calcutta. But
ah,
mm,
that's great.
yeah, so here she's blessed to have Alina. Right, so we had such a lovely evening thanks to Prema and Padma.
Thank you, Preeti.
And thank you, Sai. Bring more speakers, Sai.
Sure, ma'am. Thank you, ma'am. Ma'am,
Let's
actually, I'd like to mention that Prema ma'am actually studied in Kannada medium till her class 10. But she speaks really good English, and I'm so proud of her that she presented a paper today, ma'am.
Yes, yes. And even Prema ma'am, and then the other ma'am, but Padma Bhatt?
Shrikala Bhatt, ma'am.
Yeah,
Her name is Shrikala Bhatt, ma'am.
Shrikala Bhatt, ma'am. Convey our regards to her, and both your professors have made such a significant contribution to In Tandem. Thank you. I think
Thank you, ma'am.
all the sleepy In Tandemers should wake up now. I'm Nisha, come on, we need to have papers from all of you. We haven't had in a while. So
What's the
thank you.
next topic?
The next one, Nancy, what's the next one?
Life science, ma'am.
Life sciences.
Okay, good,
This
good.
is an answers, ma'am.
Who's presenting, sir?
Ma'am, I would like to present, ma'am.
Okay, okay. Great. You're most welcome. Thank you, Rufus, sir, for joining and all the faculty here.
Dr. Rufus is back after some time. Was not present last time.
Yeah.
Yeah.
Gordon's incompleteness theorem.
Somebody
Can
must
we?
have written, no? Somebody must have done something on this. Must have explained it with literary. I'm sure in some poem, in some poem or some essay. This must have been there. Looks like a theorem which can be put into
It
method.
sounds like, yeah, it sounds like something we would love to use.
Yeah.
Even it's something to read up about, Alina. Thank you so much.
Yes.
Yeah, actually, the idea of infinity itself, no? The
Yes.
way it's explored in literature, and oh my God, that is really that's one endless topic. The idea of infinity. Mm.
Yes, ma'am. We have one Cantor's solutions for infinity, where he says that there are different kinds of infinity. Cantor is a mathematician, so he says about various kinds of infinity, and he makes his explains his infinity paradox through a hotel. So,
Mm.
if there are infinite rooms in a hotel and there are infinite people, how will you set them in? And if suddenly a bus comes where there are many more people, so how are you going to accommodate them in that room? So there is a whole new branch of mathematics on infinity devised by Cantor.
Mm. Don't know whether this will also border on fantasy literature, because there might be some logic to fantasy also.
Ma'am, many detective novels also will lead to this, right, ma'am?
Mm. Could be, ma'am.
Actually, yes.
Detective fiction, uh, they use unique skills and methods, ma'am, like Sherlock Holmes by author Conan Doyle,
Yeah,
ma'am.
yeah.
Sherlock Holmes has been has used a number of, I think, explained a number of mathematical propositions in his through his
Actually,
like.
more than Holmes, I think Moriarty is the mathematician.
Yeah, yeah, right. That he's
That's
supposed
it.
to be. There's something,
Yeah.
some connection there.
He's written I think he wrote a treatise or a monograph on asteroids or something using mathematics. And we also have a lot of detective stories where specific mathematical theorems are used or calculation of dates using mathematics is done. Isaac Asimov, who's generally known as
Yes,
a science
yes.
fiction writer, also has a detective series, as in a mystery series. It's called the Black Widowers Club stories. And in that, you have a lot of they're short stories. A lot of the short stories actually revolve around mathematics, and it takes a little while to understand unless you're tuned into that. In fact, one of them also revolves around the idea of the base. What base number are you using? Is it a 10 base or a 2 base or all of those? You could try to read those also. They're really interesting.
And ma'am, we have another set called lunar mathematics, which is something which inspired even Lewis Carroll to write this Alice in Wonderland. So lunar mathematics might seem like nonsense to us. So that inspired him to write a nonsense as well, as because he was the mathematics professor at Oxford.
I think Padma, there's somebody called Sukumar, some writer of detective fiction from Bengal. He uses a lot of, I think, mathematics also in his. Basically, I think it is detective somewhere, or it's humor too.
Satyajit Ray uses a lot of mathematical calculations in his detective writing.
Alina, you're from Bengal, so you have read some.
Yes, ma'am. We have some very good detective books, and uh, we have been flooded with detective novels right from our childhood. And people are in Bengal would be telling to read those novels. Not only those novels make us aware of the present scenario, they also uh, eh, increase the level of intellectuality of even children.
That's interesting.
Yeah.
Padma, I also wanted to, give us my penny worth of observation that imitation, no, this imitation, the idea of imitation, which we come across in Aristotle and all that. That we say that art imitates reality, but imitation is so central to all innovation, right? The